Grade 9 is new to the series, so welcome grade 9. Ideas at Neev is a series to get you to think about different spaces of work and how they are bringing knowledge and the application of knowledge, moving it forward, right? This year we are critically focusing on science. Science at the intersections is the goal. As a series from July to December. This is aimed not just at building your knowledge but also to get you to think about the projects critical projects like personal project, extended essay, to think about those differently. Looking at this series, we'll look at the history of science, evolution of scientific knowledge within disciplines and the applications of science. Why science? Science, technology and innovation are the source of progress and prosperity. In some ways, humanities asks questions and science pursues answers. Human lives were nasty, brutish and short, as Hobbes said, before scientific temper infected human beings. It's true that science is a greedy subject. And you need depth of knowledge before you get into looking at the problems and seeking answers. But thinking about the problems alongside the build-up of your knowledge is important to know where the future lies as you approach this world. And also what areas you might want to research further through the opportunities, the multiple opportunities that you have in your programs. Knowledge is a strange thing, and we spoke about that the other day in the assembly. The pursuit of knowledge to get to wisdom and intelligence in some ways is the pursuit of science or scientific thinking. And it's an endless pursuit, but it's worthy, meaningful and inspiring. Even if you pursue careers in humanities in the future and other fields, scientific thinking in today's world is an essential mindset, as even the Nobel Prize winners' work, Abhijit Banerjee and Esther Duflo, has shown us with randomized clinical, with the RCT work, right? So I'm going to call Sahasra to introduce our speaker today, Jahnavi Phalkey, Dr. Jahnavi Phalkey.
Good morning, everyone. I am honored to introduce Dr. Jahnavi Phalkey, a distinguished historian of science and technology whose work is significantly contributing to our understanding of the interplay between science, technology, and society. Dr. Phalkey is the founding director of the Science Gallery, Bengaluru, an institution dedicated to promoting public engagement with science through innovative exhibitions and programs. Her vision and leadership at the Science Gallery have been instrumental in creating a space where science meets creativity and public discourse. Dr. Phalkey's academic journey is impressive as it is inspiring. She holds a PhD in history from the Georgia Institute of Technology and has held prestigious positions as a senior lecturer at King's College London and a research fellow at the Wissenschaften College Zoo, Berlin. Her research focuses on the history of science in India, and she has extensively studied the development of big science in the country during the 20th century. She is the author of the acclaimed book Atomic Science, Big Science in 20th Century India, which explores the history of nuclear science and the political and social ramifications of scientific advancements in India. Her work has been praised for its scholarship and insightful analysis, shedding light on the complex relationship between science, state, and society. In addition to her scholarly work, Dr. Phalkey has curated several important exhibitions that have brought science to the public in engaging and accessible ways. Her exhibitions have been celebrated for their ability to make complex scientific ideas understandable and relevant to a broad audience. Please join me in welcoming Dr. Jahnavi Phalkey.
Can you hear me at the back? Properly? Excellent. Okay. Thank you, Sasha, for that warm introduction, and thank you for inviting me to speak to all of you. I haven't been back to school in 3 decades, or maybe more actually. Maybe 3.5 decades actually. So, and I'm still as nervous and frightened as I was when I was a student. Needless to say, school wasn't my best time. It did get better for me after that. So, I'm here today to share with you my learnings from the history of science, which is my primary discipline, on science in the times of crisis. I was earlier going to present contemporary crises towards the end after speaking to you about 3 specific cases of science during crisis, or science in crisis. But let me actually start with what I was going to end with, because I have a feeling, given that we also have younger colleagues with us today from grade 9, I'm told. Yeah. So, given that we have younger colleagues, let me start with contemporary crises so that you get a handle or a hook on what I mean by science during crises. Right? So, how would we today understand crises? Does anyone have an idea of what we would call a crisis today? During your lifetime, which has been shorter than mine. Yes, please go ahead. Say that again. Yes. So what would that urgent difficulty today look like? So do you have an idea of what a crisis today is? Any crisis today? Pandemic. Excellent. Yeah. Say that again. Climate change. Absolutely. Yeah. Today's crisis, what would you identify as today's crisis? So your colleagues here have identified the pandemic and climate change, exactly in the direction that I was thinking. Huh? Scarcity of resources. Yes?
A crisis is also a global shutdown of infrastructure.
If that happened, yes, when you have massive ships blocking a channel and the passage of goods and services, yes?
Something like the South African water crisis.
Yes, so water crisis. So scarcity of resources, I would fold it under that. So, yes, last one. Conflicts. Absolutely. So today there are at least 2 globally recognized situations of war or warfare. There are many more. There's a war going on in Mali as well, which we don't talk about so much, and there are others too, but yes, war. Crises today are exactly as our colleagues here today have identified. So there's climate change, there's pandemics, there's new genetic technologies, new medical technologies that we are looking at. Now why do we call these crises? These are new research and technologies making their way into our lives in order to address situations that appear to us as crises. The pandemic was definitely a big one, and I'll speak to it in a second. But also scarcity of resources, and again, the 3 cases that I picked, one of them goes back to scarcity of resources and warfare. Now, what kind of research or what kind of science do we need or do we see emerging, right? So, it's always difficult. What happens when you look at any phenomenon academically or through research is that one tends to often get mixed between the normative, meaning this ought to be like this, and the analytical, meaning we understand this to be like this, right? So my effort today is going to be one of trying to keep the 2 separate, right? We can touch the normative, meaning how things ought to be later, maybe also during the Q&A, but let me focus when I'm speaking to you about what is roughly clubbed as the analytical, meaning how are things when we observe the conduct of science and to some extent technology during times of crisis. And we'll come back to these contemporary crises that we just discussed also towards the end. The 3 cases that I wish to discuss with you today are the following. The first is science during the Second World War and the making and the use of the first atomic weapons. The second is specific to India, which is, I'm going to discuss it specifically with India. I'm going to discuss it specific to India. See, but this is what happens when you come to a school, you try to get the grammar also right, because I'm sure there's somebody sitting here observing our grammar. The Green Revolution. It was a largely global phenomenon, but I'm going to discuss it in the context of India. And then lastly, the pandemic, as we saw it globally, but also again back specific to India. Now, before I speak directly to the Second World War, let me say very, very briefly something about the First World War and the use of poison gas. It was during the First World War that we saw the use of poison gas, which was developed in fact in an industrial research laboratory. Yeah. Now, this was conduct of warfare. It was science that was mobilized in the context of warfare. So research can be mobilized during warfare is something that we learned very seriously during the First World War. And this was different kind of research when compared with earlier wars. Earlier wars usually had human beings as cannon fodder, and they were less effective in terms of losing people, right? But I'll not speak to earlier histories because the minute I run into areas before the 20th century, I start getting uncomfortable. The 20th century is the most comfortable. So now let's speak specifically to the Manhattan Project. I'm guessing most of you have seen the film Oppenheimer? Yeah? Okay. So here's what happened. What you have in 1938, towards the end of 1938, the discovery of nuclear fission. The paper, as some of you may have even explored, because you run down rabbit holes once you see a film like Oppenheimer, the paper was written by Lisa Meitner and Otto Hahn, two physicists. Lisa Meitner, in fact, running away from Germany in 1938 because she was of Jewish descent. The paper spoke about nuclear fission and it brought it to light. The minute the physics community found out about nuclear fission, everyone who understood nuclear physics understood the potential of nuclear fission in making an explosive, meaning making a bomb. So anyone who knew anything about nuclear physics then knew that a nuclear bomb was possible. Now nuclear physics was a very, very new discipline. It was about 6 years old in 1938. 1932 is called the Annus Mirabilis of nuclear physics because that was the year the atomic nucleus was split open at the Cavendish in Cambridge. The positron and the neutron were also discovered experimentally in the same year, which led to the establishment of a subfield which very quickly was going to become the frontier of not only physics but also warfare and state policy. So like 1932, you have the beginnings of experimental nuclear physics. 1938 was the end of 1938. You have the understanding that nuclear fission can accomplish an incredibly sort of strong and powerful explosive device of the kind that the world had not seen before. Now, this led to some physicists writing to the American president and stating that this is a finding that comes from German physics, or German physicists rather, which means that even if the two key people have left Germany, their students, their colleagues, everyone is there, and moreover, people like Werner Heisenberg are still in Germany. Which means, if a bomb can be made, the Germans will make one. And if the Germans make one, they will use it. And if they use it, they will win the war. And therefore, it is imperative for the democratic and free world to come together to make a nuclear bomb, or an atomic bomb as it was more appropriately called then. The result of this saw mobilization at a scale unseen before. There are various comparisons that are made about the kind of budget of what came eventually to be called the Manhattan Project. 4 times the budget of peacetime Norway, so on and so forth. So you guys know how to use the internet far better than I do. You can find several comparisons. It was a massive, massive budget running into millions of dollars. Facilities were set up. Incredibly large facilities employing thousands of engineers and chemists and physicists were set up across the United States and also in Canada. The Canadian part of the project was called Chocolate. In these projects, not only were American scientists and British scientists and Canadian scientists involved, but as we saw in the film Oppenheimer, a range of scientists were fleeing war in Europe, Second World War, because as you know, in 1939, the Second World War broke out, right? So many Hungarians, especially physicists and mathematicians, Italians, Enrico Fermi, and Germans moved to the United States. There will be a second kind of migration at the end of the Second World War, but we'll wait on that for a few seconds. There's a lovely murder mysteries are lovely. There's a lovely murder mystery set in Los Alamos, which is where people like Robert Oppenheimer and Edward Teller and others basically work together doing the calculations to understand what it would take to create an explosive device. Right? Now, this project was at a large scale in terms of budget, in terms of the people it employed, and the kinds of people it employed. Right? So the person who was heading this project was, on the one hand, Robert J. Oppenheimer, on the other hand, General Leslie Groves. And the struggle between the two constantly was as follows. The physicists found what in hindsight, we looked into the document, although it was said by Edward Teller and Ulla, it's something that speaks to also what Oppenheimer and others were trying to do during the war with that kind of budget and that kind of equipment and that kind of people at their disposal. The problem was sweet. How do you understand what it would take in terms of critical mass to explode or to use a device at a particular intensity, right? So they are working on this project intensively together with the Europeans and others. Now, this is probably the most spectacular example of what happens with science. I wouldn't say to science, although there's an aspect to that. But what happens with science during times of crisis, which is warfare, especially starting with the First World War, but culminating in an incredibly strong way during the Second World War. Now, why is this important? It is important for several reasons. If it wasn't for the Second World War, the fact that nuclear fission was possible would not have necessarily led to accelerated efforts leading to, in less than 6 years, the creation of an explosive device. Nobody would have had the kind of resources it took to put together the Manhattan Project and create the atomic bombs or the atomic weapons. During peacetime, it would have been literally impossible to have that many extremely high caliber mathematicians and physicists from across Europe, across the United States, across Canada, and across the United Kingdom coming in one place with that kind of budget, those kinds of facilities, those kinds of resources backing them to be able to create something this devastating but also spectacular within a 6-year time period. What would have most likely happened if the discovery of fission had happened during so-called peacetime, right? Like if there wasn't a war at the mouth of the discovery of fission, we most likely would have had concerted, long-term, slow efforts to realize the energy potential of fission, which means a pile, as it was called then, which is what Enrico Fermi, the Italian physicist, worked on nuclear reactors, as they came to be known after the Second World War, would have been most likely the first devices to be developed rather than atomic weapons. This is not to say that no country would have possibly in secrecy developed the potential or the possibility or worked out the possibility of an atomic weapon, but at this scale, it is almost impossible to imagine this would have happened. Historians are not particularly good with counterfactuals. Often if you ask a counterfactual to a historian, they will dilly-dally and give you a wishy-washy answer. But I think in this case, and this is why crises are very, very important precipitors, it is fairly accurate or fairly plausible, not even plausible, it's much more than plausible. It's fairly accurate to say that we would not have seen the development of atomic weapons had it not been for the war. So this is very, very important to remember. And this, of course, had very serious aftermaths. And let me list out a few things for you. If you ever have the misfortune of listening to me again, some of this I will repeat elsewhere too. Now, before the Second World War, there was practically no state or no government that had a Ministry of Science and Technology. After the Second World War, you will not find a single government, or you're most likely not going to find a single government which doesn't have a Ministry of Science and Technology. So the coming together of science and technology and government, or what some sociologists of science have called reasons of state, right? So science became a reason of state and deeply embedded in ideas of governance, in ideas of even state formation. So when I wrote the book that, what was her name? I mentioned atomic state. What we saw, and that was a very, very interesting convergence of coincidence and contingency in the Indian case. That Indian independence came within 2 years of the first use of atomic weapons. As a result of which, the governance of nuclear research or governance of research at the frontiers is deeply embedded in how the Indian state was even formed. What does that mean? It means agencies for the governance and regulation of how scientific research is conducted is deeply embedded in how we imagine even how the Indian state would look like, what kind of agencies it would have, but also what kind of structures our research institutions would have going forward. This is not true only of India, or rather this is true of places beyond India. One of the key decisions that was taken at the end in fact a year before independence and then flowing into independence for India was that of centralization. Because if the Manhattan Project took 4 times the peacetime budget of Norway to be made, what kind of resources would it take for a single country? I mean, and I'm not even talking about the kind of qualified people one would require to run anything like this. I'm just talking about budgets. Therefore, centralization of nuclear research, of experimental nuclear research, was a decision that was taken across the world. And see how deeply it became implicated in politics. Because it became all about warfare. So the Indian decision was to have one centralized nuclear research facility, which later became the Hava Atomic Research Center. When it was established, it was called the Atomic Energy Establishment of Bombay, because it was in Bombay. Now, India wasn't the only country to take a decision for centralization. And again, remember, crises, right? Like India is emerging from a crisis of not only the decline and end of imperial rule in 1947, but also partition, right? So India is also in the mid-40s in a moment of crisis. Global politics is in a moment of crisis. The global world order, as we knew it before the Second World War, is in crisis because it's no longer a world order led by Europe through imperial rule, but it is a world order that very quickly congeals in the late 40s into the Cold War, which becomes essentially largely a 2-block rivalry between the United States and the Soviet Union. Right? So the crisis is at various levels, is being enacted at various levels, including at the level of the laboratory. What you can do in the experimental nuclear physics lab and what you cannot do is no longer decided only in the lab. It's decided at various levels, including the state, meaning the government, but also the geopolitical model. Right? So there are many, many strands or many, many registers through which science gets filtered, filtered is the wrong word, enacted and tangled and shaped. So, and and this is a very, very specific instance of the conduct of science during a crisis, but also the aftermath of it. Therefore the aftermath of it as a result of it having been shaped during crisis. It ends up shaping the state, it ends up shaping what form research institutions will take after it's conducted, but also what's actually eventually done in the lab or not done. Because certain kinds of equipment can no longer be built or purchased. If you don't have the industrial capacity to build devices, then you can no longer buy them on the international market because they are dual-use technologies. What are dual-use technologies? The technologies that sit on the fence between civilian and military, right? So you could no longer buy dual-use technologies on the international market. Europe was devastated by war. The only credible superpower, so to speak, economically, but later also very quickly also politically, could have been the United States and the Soviet Union, so the Soviet Union conducted their first nuclear tests in 1949, within 4 years of the first use of atomic weapons, which completely shocked the United States because that was not expected. This was far too advanced a science for any country to have conducted, was the belief at the end of the war in the United States. That was the first shock in 1957, which is the launch of Sputnik by the Soviet Union, was the second shock, which led to then, and this is the last thing I'll say about the Manhattan Project, and the rest I'll answer in the Q&A. In the 60s, after Sputnik, early 60s, after Sputnik, John F. Kennedy declares in his speech, "We will put a man on the moon." If you look at the ambitions of governments and nation states before the Second World War and earlier as well in the 19th century, they are articulated very differently. It's about wealth, it's about military might, it's about control over territory. What you have in the second half of the 20th century is statist ambitions being congealed in the conduct of science and the making of technology. You make rockets, you make bombs, you make supersonic jet fighters, you make these kinds of things. That is the manifestation of ambition. Yeah? So, let me speak a little bit to the Green Revolution. This retreat, I alluded to India in the case of experimental nuclear research. Let me speak a little bit to the Green Revolution. It is interesting that among the many origins was most phenomenon, most historical processes, most transformations, and many points of origins. Things converge and transformations happen. But one of the Green Revolution's interesting moments of origins is in the early 20th century with another party. In India, a bunch of young people called seditious by the British Indian government who escape India. Most of them go to California. Some of them then move on from California to elsewhere. One person amongst them, his name was Pandurang Khan Koje, was from Maharashtra. When he went to California, I'm cutting a long story short, for those of you who are interested, there's a book which I can recommend to you later. He studies agriculture in California and then moves on to Mexico. In Mexico, he makes friends with largely a bunch of Marxists and communists. Interestingly, and this is an aside, I know I shouldn't make too many digressions, but this is an aside. The Mexican Communist Party was established by Manavendranath Roy, an Indian. Hancock makes friends with, among others, Frida Kahlo, Diego Rivera, and a bunch of revolutionaries and radicals in Mexico, starts working with farmer schools, free agricultural schools for farmers, where he starts experimenting on maize. Those experiments, which are recorded in fact by an incredible Italian photographer called Tina Modotti, They're beautiful photographs. If you will share them with you later. He does his experiments there. Those experiments become the foundation for experiments on crops to yield more, basically so high yield variety cropping, right? That is the research he lays the foundations for in Mexico, which leads to later, and I'm talking about later as an after the Second World War, establishment of research institutions working on grain for production, highly productive crops. That feeds into the ideas then that flow back to India. Pankaj of course returned to India, but those ideas return via the Rockefeller Foundation and the United States to India during the Green Revolution. Now, how and why the Green Revolution? And why did I tell you the Pankaj story? Apart from it being interesting, of course, as a sort of science for me. It is interesting because, like we see in the case of the Manhattan Project, but also we will see for the Green Revolution and the next case we'll speak about, which is the pandemic, research has always been happening over a long period of time, and it congeals in times of crisis in highly specific ways. Right? So, it's not that crisis precipitates new forms of research like that. What it means is that crisis allows for us to pick up those options that can be very, very quickly turned around in a useful manner to address the crisis. We saw that with the Manhattan Project to some extent. So 1932, 1938, and then 6 years and quick turnaround for the bomb. Similarly, for the Green Revolution, research of the kind that Kankoji did, but also others did, fed into what eventually became the Green Revolution. Now, why was the Green Revolution an answer to a crisis, or what was the crisis that the Green Revolution was trying to address? What we had in India after independence, and especially in the 50s, late 50s, early 60s, is conditions of drought and conditions of food scarcity. Right? It's not quite food scarcity at the level of famines, which we saw during imperial rule and at the end of imperial rule. In fact, just as the British were leaving India in 1942-43, we saw severe famines, largely man-made, because of a brutal management of how food would be distributed, who would get the food, and where it was okay to not supply food, right? Or where do you, in a way, redirect food from? So famines have often been man-made, especially on the Indian subcontinent. But coming back to the late 50s and early 60s, when we saw a rise in the Indian population, but not a matching rise in in agricultural productivity to be able to feed that population. But it was a crisis also because India was not able to secure food aid by way of grains, not able to secure grains at reduced cost. So import also was proving to be difficult, but also especially the distance that was growing between the Americans and the Indians. Right? The United States was an important donor for India for food, but the growing distance between Mrs. Indira Gandhi at that point in time, and the American President Nixon meant that food became, or other grains, food aid became a very difficult topic. And the answer on the ground was that we need to increase agricultural productivity. Now, I'm explaining a rather complicated story in a slightly simplistic manner. There are incredible books written by my colleagues about the Green Revolution. But what it precipitated was a push for agricultural productivity such that India would be able to feed her population going forward. And the 60s then saw the use of high yield variety seeds in order to have better crops, crop yield, and therefore be able to feed our population. Now, outcomes. Like we saw in the Manhattan Project, several outcomes, a rearrangement of state agencies. What the Green Revolution saw, so this was again research brought to bear upon a crisis, which was a food security crisis. The result was that India was, as starting in the 70s, able to get better and better at producing food at home and feeding her population. It led to a redistribution or rearrangement of land ownership, which led to another kind of crisis, which I can answer later. I don't know much, this is my weakest case because I'm reading other people on this. Manhattan Project is my own research. The pandemic we all went through. We also saw the high use of, among other things, pesticides, the introduction of irrigation in areas where there was no irrigation before, and growing crops that were not native to certain areas, right? Like, so for example, Punjab is a case in point, where we've been growing rice in a not so rice growing area. It has led to not only change in land holding patterns, which contributed in no mean way to the crisis, the political crisis in the Punjab in the 1980s and especially in the 1980s, but also salination of soil because of the pesticides. Maybe I mentioned that already. So what it did was it rearranged social relationships, the patterns of ownership of land, and so in a way it changed the structure on the ground. So there are outcomes to mobilizing research during crises, always in unforeseen ways. Historians of technology often call these unintended consequences of the making, shaping, and use of scientific research as well as technologies. Let me say a little bit now to the pandemic that all of us lived through. Since the Spanish flu, I think this was the biggest pandemic. The Spanish flu was in the early 20th century. This was the biggest global pandemic we saw, biggest global public health crisis we saw. Right? Generations haven't seen this crisis. Millions died in the Spanish flu, millions also died during COVID-19. Now, a bunch of things to look at in terms of scientific research. Now remember, clinical research, medical research, one could never say it's not scientific, but it's always, almost always on the edge, right? So, what do I mean by that? An edge of what? Research in physics, apart from extremely specific examples, like the making of the atomic bomb, it's very hard to find a social interface that responds to a crisis, right? In physics, in mathematics, chemistry, that's not the case. Chemistry, in fact, is very much, we can actually trace the interface with society. With clinical and medical research, the social interface is extremely strong because it affects the health of human beings, right? And therefore, the conduct and the effect and the affects of research are highly determined or shaped by human behavior. And this is what I often say. I make a joke about the so-called hard sciences and soft sciences. It's not accurate, it actually doesn't hold, but it works as very, very bad rhetoric, and you can use it in a fight with someone at a table, but it doesn't hold for very long, so be warned about that. We often say physics and math and engineering are sort of the hard sciences, and that the human and social sciences are soft sciences. The joke I make is that, in fact, the human and social sciences are much harder because humans are doubly unpredictable. There is no way to tell what a human being or a cluster of human beings are going to necessarily do. Unlike atomic particles, which by and large perform to expect. That's the extent to which this works. This doesn't work when you take it much further because obviously they're not called the hard sciences because they're difficult to do, but because data is supposed to be more reliable in the physical sciences and engineering as opposed to the human sciences and social sciences. But anyway, coming back to medical and clinical sciences, which is again an area where human behavior shapes the outcomes of this research so strongly that one has to be attentive to it when understanding what it is. But I'll take 2 steps back, because what happened during this pandemic? Very quickly we saw, I think when I was looking at it carefully, and then at some point, like everybody, I decided to retreat into my own head. There were about 135 vaccines in the making, very early on, right? Like in 2020. What does that mean? They didn't come up overnight, right? So speaking back to the point that I was making earlier, it meant that there was research that was ongoing for several decades that was brought to fruition because a crisis demanded that we now accelerate the development of those technologies. Most prominent amongst them was the mRNA vaccine, for which we did not yet have the full cycle of tests that other kinds of more established vaccines have had. Yeah? So what is it that we saw? Research was mobilized for the making of vaccines to address a pandemic which was largely shaped and determined by human behavior. But these vaccines were, and that behavior not only meant whether you socially distanced or not, but also whether you actually accessed the vaccine or not. And then also which vaccine you accessed, if you did. So, when you look at the outcomes of the pandemic, what we come to understand, and the Nobel Prize awarded to the 2 clinical researchers who developed the mRNA vaccine, for example, and the kinds of awards that others have seen as well, and the recognition that they've seen, tells us that they worked on this project for decades in order to be, in many ways, ready to address crisis. Right? So, I'm trying to pull this together to say that crises come in various forms. It could be war, it could be a pandemic, it could be it could be hunger, scarcity of resources, as our colleague said right at the start. Crises are precipitated by the convergence of many things, natural as well as not so natural. Some crises are man-made, entirely man-made. Some crises, like war, some crises are a combination of natural factors, accelerated or shaped or determined in particular ways by human responses and behaviors to that. Research gets mobilized and accelerated in times of crisis to meet the crisis, because we have also come to see by the 20th century that science and technology offer solutions to problems. Technical or scientific solutions to what may be social or a combination of social and natural problems. Now this, coming to the normative, could call for an investment in research without the anticipation of its ability to address crises immediately or problems immediately. So funding research that may or may not appear to be useful right at the get-go may still be funded, because one never knows at what point it may become useful. People studying bats, for example, right? People studying bats suddenly found themselves in the middle of interest during the pandemic, because we needed to understand how this is transmitted. At least that was one of the factors, one of the axes we studied. So this, one of the normative arguments one could make is that of funding research across the spectrum in order to remain curious, because it's still about the physical world around us, it's still about this incredible planet that we inhabit. The second is that one should always remain attentive to the fact that crises, the mobilization of scientific research and the use of technology during crises leads to outcomes that may or may not be anticipated. It rearranges social, political, and economic structures in various combinations and ways which are not necessarily predictable. but they can be anticipated, and therefore remaining alert to them is very important, which calls for an important role not only for natural sciences but also the human and social sciences to be equally valuable or be equally valuable in understanding and responding to crises. And there should be a third. I usually like to speak in threes. We are in a moment. I think we are living in a moment of the kinds of crises that have been shaping up for long. So it's not crises that we haven't been aware of. We've been aware of climate change, for example, which is a serious crisis with several components, critical components which are equally individually definable as crises. So urban heat islands, rising sea levels. So these are individually crises depending on where you live. So if you live in a largely landlocked area, urban heat island, if you're living on the coast, the rising sea levels, etc. But collectively, climate change as a crisis is something we've been aware of. It being in development for a long time. Crises that develop over, how should I say? If it's crises that don't immediately strike you as crises, like a war or like a pandemic, are much more difficult to register and act upon. And research, when even available, is not necessarily mobilized in ways in which it could be. Its outcomes, therefore, are there for us to see. Not necessarily evident, but most certainly palpable. And so I think, at the end of the day, the relationship between crises and research is one that is important, one that reshapes how we live and how we continue to live, and one that we might pay attention to, especially given how we have shaped our lives on the planet and the world. Thank you for your attention.
Thank you so much, Jahnavi. We pretty much covered my questions. Kids, I'll ask a couple of questions, follow-up questions to Jahnavi. And in the meanwhile, you think about your questions. I have lots of questions which I can ask from what she spoke about as well, besides what were already there in my mind. But as soon as I see your hands going up more, is when I will stop asking my questions and turn it over to you. So I'll start with a couple of questions. I love the way you brought that together. One of the things that I said in the opening, Jahnavi, was that while humanities asks the questions and science provides answers, what I wanted to say is humanities creates the problems and science provides solutions. But what you brought together beautifully is that humanities actually takes those solutions and makes something happen with it as well. So that was wonderful. I'll just address some of the big questions related to the three areas, and I'm categorizing them as ethics and morality questions for the older problems and more scientific and bringing together leadership current tools for the pandemic. So starting with the Manhattan Project itself, and you said the counterfactuals of history are not worth getting into. So not the what ifs, but Einstein was one of the scientists who wrote that letter to Roosevelt to say that this is what is happening in Germany and we need to put this together. But Einstein was actually left out of the entire research categorically because of his political leanings and his origins, I suppose, right? At the end of it, way later, he actually wrote that had I known the Germans would not succeed in developing an atomic bomb, I would have done nothing. Oppenheimer also reflected, very nicely seen in the movie, when he was questioned on does he have moral scruples about what happened, and he said terrible ones. So question that I'm asking is and you spoke about how the decisions moved away from the nuclear labs to many other spheres at that point. Does science have morals? And how does that come about? How does that get questioned? Thoughts?
Okay, so I trained as a historian of science and historian of technology, and the founder chair of the department where I studied, which was at Georgia Institute of Technology, Georgia Tech, Atlanta. His name was Professor Melvin Transfer, and he wrote an essay called 6 Laws of Technology. And the first law, which I, again, if you have the misfortune of listening to me on other occasions, you'll hear me say this again and again because I believe it's very, very important. He said this. He said technology, and this can apply to science too, technology is neither good nor bad, nor is it neutral. Right? So it's not simply a matter of mobilizing science and technology for good or for bad. Scientific research and technology embody the ambitions and the values of the people who make them. They also represent the values of the time in which they are made. They are products of their time, they are products of the morality or the zeitgeist as we call it, the structure of feeling of that moment, right? Certain technologies get made in certain moments in history, and therefore they are not neutral of the context or the morality in which they get made. And it's a tough one, right? Like so this is to say that it is not neutral. It cannot be neutral. But I know the question you're asking me is, can something like this be anticipated, and can something like this be brought into consideration in the conduct of research? And here's an example to follow up on. Edward Teller and Stanislav Ulam were the two people who worked on the hydrogen bomb after the first use of the atomic bomb. Now, the capacity for destruction of atomic weapons was well established when Teller and Ulam began to work on the hydrogen bomb, which would have several thousand times the capacity of an atomic bomb. But they worked on it. They worked on the calculations, and that is the statement that I used, that I quoted earlier. The problem was their explanation for why they worked out the equations to make the idea of the hydrogen bomb possible or realizable. Right? Now, does one say then that Teller and Ulam had no ethics or no qualms or no morals? It's a very, very difficult question to answer. There are times in life when one feels that, of course, they shouldn't have. There are times in life when you feel, how could they not have? That's not to say you already anticipate the use of the hydrogen bomb. The hydrogen bomb has never been used on human populations. But solving that problem was important to Teller and Ulam for two reasons. One, because someone else was going to do it if they didn't do it, which was exactly the feeling behind Einstein and others pushing for that idea. And that's not a trivial idea when lives and national sovereignties and destruction and a range of other things are at stake. But the other question, which is probably an even more difficult one, is to say, should we then not solve these problems at all? Should we not be curious about what it would take to make a hydrogen bomb once you know it is possible? And it's a question for which I don't have an obvious answer. Or at least an answer that will convince anyone. Right? Because I think it's very hard to say we will not be curious about something because it has the potential to destroy. Because you could also very easily say, I would like to know more about this because this has the capacity to destroy. So if we want to stop this from ever happening, then we need to know whenever anyone is trying to do this, and therefore we need to know what's what's happening, right? How would you detect the use of a hydrogen weapon? You'd have to know what it would emit, what kind of radiation it would emit after its use in order to know it was used, for example, right? So on and so forth. But even if it wasn't so obviously destructive and morally difficult a case as the atomic bomb, I think it's very hard to say we will not be curious about this because it holds a morally difficult choice embedded in it.
So science can be, if science can be explored, it must be explored but done with responsibility.
Is what I would agree with.
Is where we are. And I think science in a crisis, they say is science in a crucible.
Yeah.
And you are experimenting, the ethical questions arise almost alongside the development of science, right? We know that, and we were in Japan recently, my son, a pursuer of history, actually went to Hiroshima, and I looked at the photographs, I looked at the numbers after that of how many people died on Hiroshima and Nagasaki, and it's shocking that the number is not known, actually. It's actually estimated to be between 100,000 and 240,000, which is unbelievable that how would they not know. But the fact is that the atomic bomb also stopped World War II, ended World War II in many ways, and stopped future wars in some ways. When you look at the fatality of World War II, which is 15 million military, 38 million civilian lives lost, seems logical to be stopping something like that, right? I'm going to keep asking questions, people. Put your hands up if you have questions coming up. I'm going to move to the Green Revolution. And I didn't know about this history of Pandurang Kankoje. That's interesting. But Charles Mann's book, The Wizard and the Prophet, is just wonderful. And he talks about the wizard, who is Norman Borlaug, right, the father of the Green Revolution, who invented high-volume crossbreeding, resulting in the scientific revolution of agriculture, but that resulted in the positives, which was hybrid seeds, synthetic fertilizers, irrigation methodology, and that became the Green Revolution, and ending hunger in the world potentially, as per so many different accounts. But there were costs, diversity of crops, excess fertilizer became a pollutant, and you also spoke about the industrialization of farming, which led to actually ending of the small farmer movement, right? William Watt, who was a prophet, spoke about, and he was the founder of the environmental movement in many ways, spoke about the limits to growth, ecological overshoot, planetary boundaries. And that war keeps raging on with all this organic farming movement, all of that, right, that we talk about. Where are you on that? Are you with the wizard or the prophet?
Yeah.
Whose side are you on? Norman Borlaug? And that comes up often, right?
Yeah.
So it's, are you on the side of the wizard or the prophet as a historian of science?
See, historians like to sit on fences and say we observe everything, we don't tell you what's good or bad, we tell you how it happened. But no, I will take a stand. I will take a stand. See, one of the reasons why I did not name Borlaug in specifically and name one potential origin story is because often what we do is we come to hang our stories on heroes, and these are, as we know, I mean, even in India, MS Swaminathan, for example, played a very, very important role. But there were also other agricultural scientists who had been working in experimental stations starting during imperial rule, right? So, high yield variety, better commercial cropping in order to get, well, more food, more profits, range of things, right? So crop optimization for an outcome that is desirable has been going on for a long time, right? Like, so we saw that with sugarcane, we saw that with indigo, we saw that with jute, and a range of other crops across India, but also other parts of the world that were under European imperial rule. So coming to the profit and this and limits to growth. Now, again, like with atomic weapons, it's a very difficult choice. You can't choose between feeding people who are alive and thinking about how are we to inhabit a planet which has limits to growth the way we understand it today, right? So this is not only about agricultural growth, because we are not only feeding population, we are also conducting agriculture for industrialization. Everything from biofuels to fodder for the beef industry, beef and pork industry. So Europe and America, massive swathes of land are dedicated simply for crops to feed all kinds of animals that are slaughtered for food, right? So, there is no doubt that there are limits to growth. This planet cannot endlessly produce what we are expecting of it. Our lifestyles have changed considerably, and what we aspire to have is not simply an end to the scarcity of food, or not even is not simply about food security, but a range of things that go with it. Right? So I think it's Borlo, Swaminathan, Kamkoje, etc. took a call at a time when the crisis was one of feeding people. We are no longer in that place, although food distribution still remains a problem, because there still is hunger in the world. It's not for lack of food, because there's also food wastage, but for an arrangement of how it is distributed and access to food. So that no longer is the problem. So I think the bigger problem must flow into the problem of limits to growth and climate change, one where we understand and try to manage resources of the planet efficiently, including what we extract, not necessarily the right word, but extract agriculturally also from the planet. So I think the reserve comes after the profit comes after the reserve in a sense, right? Like, so these are consequential, not consequential, sequential in a way. Because of the actions we took to increase food production, but not only food production, right? Like, we are not using land only for food production, we're using for a range of other things. We are now in a situation where we need to pay heed to the profit. So, redistribution of food might address to a significant extent the concerns around food security, but the problem of the planet and its health is one that must take precedence.
So the prophet with temperance of the wizard, but with temperance of the prophet. Sort of?
Yeah, because we're in a different place now.
Yeah.
We're in a different place.
Yeah. So on that question of we're in a different place now with the COVID pandemic, leadership came hugely into question, and leadership styles came hugely into question. And there is so much that's happening after that, which is all kinds of policies and guidelines and things like that are emerging for leaders, for developing leadership capabilities, simulations that are coming up from various different bodies in the UK, in the US, all around the world, on how leaders can be trained to think through this. And we saw leadership going crazy with Boris Johnson talking about his cabinet party and Trump saying there is no COVID, right? And both of them came close to dying. And then we had Modi, who was doing his Thali Bajana and all of that, and very hard lockdowns. Is there a certain leadership style that is essential for handling today's crazy world? Is there a way to train these people? What is the capability that we are looking in leaders? I think one of the other factors was the ability to bring many people together in this time, right? It's not because it was not any one single person. Unlike the Manhattan Project, which seemed to turn on a couple of people in that moment, many more labs, but sort of brought together there. The Green Revolution again kind of came to a head because of a couple of people. COVID didn't. COVID had multiple issues, multiple aspects, and 40 million people got infected, but 1 million people died as a result of decision making. Inquiries are still going on. Can leadership, is there a particular style of leadership? Can leadership be trained for crisis management? What should the capability of our leaders be? Any thoughts? That's a very wide question.
So, people died during the war as well. People died in massive numbers during the war, right? Like not only by the use of atomic weapons, but also carpet bombing of Germany, for example, or the blitz on the Germans blitzing London and other parts of the UK, etc. So, I think in times of crises of these kinds,
like science in a crisis, leadership in a crisis also.
Yeah. So, I think.
Do we need intelligent leaders necessarily, or do we need leaders who have other abilities? Is intelligence that first requirement, or is it, or not a requirement, and we just need to find intelligent minds and be open to all of that? I'm just wondering, you have
So,
thoughts on that?
Yeah, I think crises demand tough decisions, and crises see people die. People died during the war, people died in the lead up to the Green Revolution, and even during, but not after. At least they died for other reasons, but not for lack of food in the way it was before the Green Revolution, for example. And of course, people died during the pandemic. So leadership calls for tough decisions, and we lose people along the way. And it would be ideal to not have people die as a consequence of decisions not of their making. This is the thing, right? Like mixing the normative and the analytical is a tough act. It's a very tough act because and it is demanded of you not only as a historian but also demanded of you as a leader, because you perform leadership or you deliver to leadership in a moral framework of your time, of your movement. Expectations are high. Resources at your disposal. Resources at your disposal. Jesus Christ! I'm on a broken loop. Resources at your disposal at a moment of crisis are tricky. Who do you trust? How do you take a call? How do you decide as a leader for a massive population if this vaccine is better than that? You will have no other recourse than to rely on people who are telling you things, and how do you discern one from the other? So I think this would be critical for no matter what kind of leadership, right? I often say this. I'm going to take a slight digression in order to answer this question, if I can at all, which is that, this is the reason, this is what I say often as loudly as I can, that we cannot today study the humanities without having an understanding of where science and technology are in our lives. Because if we think of what are the critical problems of today, which is climate change, pandemics, new gene technologies, artificial intelligence,
drug resistance,
drug resistance.
No one spoke about that.
We are making choices on a daily basis without understanding how to differentiate one claim from another. Right? It's coming at us. But we have to make these decisions.
And explain them in a non-scientific way as well.
No, explain to yourself, right? Like, so in order to make these decisions, you have to be familiar with that research, but also have the critical tools to ask the right questions in order to decide if one fact is better than another one. Because this is not necessarily between fact and non-fact, because even if it's a long journey, you'll probably still get there. But how do you discern between mRNA and the other vaccine, or the vector vaccine,
The AstraZeneca versus the Pfizer vaccine or Moderna.
Yeah, you can tell I missed my breakfast this morning. I'm not a morning person. So how do you discern between two in order to decide what's good for you? And that's the kind of decisions our leadership has to make on our behalf for massive sets of populations. You're not only bound to make mistakes, you're bound to make misguided or misjudged decisions as well. And I don't see there's a way out of it.
Yeah.
I don't see.
There was a whole theory of, if you do 2 doses of one vaccine, then you can do 1 dose of a different kind of vaccine and that will be effective. And then they said, no, that won't be the case, all the same. But if the same one is not available, take the other one. So, gosh,
How do you?
How do you make a decision, right?
You cannot, right?
So
You cannot.
challenging to think about what our leaders are today, and we won't answer Trump versus Harris question, who will be better. But kids' questions. Yash, go ahead.
So stand up.
Yash, then Moksha, stand up. Don't ask the question. Go ahead.
Okay, so science is of special importance today in the sense that science can both create conflicts and solve conflicts. And the best can be displayed through the.
Do you have a, what is it? Is it your watch? Is it something else? Where's the feedback from?
Call it out. Call it out.
So the best can be displayed through the man-made crisis, between man conflict and the creation of the nuclear arms, which is seen through, well, in the beginning it was the nuclear arms were supposed to solve the war, but to the end it also created a new conflict which was seen through the Cold War. It created a power dynamic, right? So
Say that again.
So Manhattan Project solved the conflict, but led to another conflict, which is the Cold War.
Yeah, exactly. So the assumption I'm telling you is that science, technology, or scientific concepts can both create conflicts and solve conflicts.
Sure.
The best can be seen through the okay. So my question is that can scientific policy ought to regulate scientific concepts lead to a more prosperous future in the sense of solving more crises and creating new ones?
There's no way to guarantee that. There's literally, so his question is, can we regulate the conduct of science in a manner such that it will lead less to conflicts and more to prosperity, right? Yeah. So there's no way to guarantee that, because if we as human beings knew what the future could hold or how the future would unfold, we'd be leading very, very different lives. I think what we are condemned to, and this was the philosopher Walter Benjamin, he used a painting, a Paul Klee painting of an angel. It's called the Angelus Novus, which is the angel facing the debris of the past, because there's no way to see the future. The only thing we can see is the past, we can't see the future. So it's a long-winded way to say it's not so easy to predict or shape the future. We do not have visibility on everything, and this is true as much as for ourselves as it is for our leadership. We have plans for our life. I had no idea I'd be standing here and doing this today, 6.5 years after I moved back to India from a job where I would have retired at the age of 70. I was teaching. I was reasonably happy in my job. It was a nice, lovely, dull academic life that I could have conducted until, I retired. I had no idea this was going to happen. I was not prepared for it. I did not anticipate it, right? And this is just one example from my own life. I'm sure you collectively have a million examples. Again, a long-winded way to make a simple point. It's very difficult to shape the future. One can extrapolate, one can anticipate, one can prepare. Yeah. Now, to the question about what the Manhattan Project did and did not do. The weapons were being made to stop Germany from using them. They were used on Japan. The Germans had surrendered before the use of the atomic weapons, so it was no longer necessary to use the weapons. There's you'll find it online if you go look for it, documents on the discussions on the use of the atomic weapons. Should we even use it? Should we use it for a demonstration effect to stop Japan from continuing the war? To say that, look, this is what we are capable of. If you don't stop, we're going to use it on you. All of this was overridden in order to actually use it on human populations. The use of it wasn't inevitable. It was considered by many actors, including military generals, at that point that this was not everybody was convinced of the necessity to use atomic weapons. The Cold War is a different piece. The atomic weapons played into it, but the atomic weapons were not causal to the Cold War, right? The congealing of two ideologies, or the world around two ideologies, happened with different motivations and for a different set of reasons. And I'll just end by also saying that and technological outcomes are accomplished under very different kinds of regimes. The Soviet Union had what one might call an extremely authoritarian, controlled, regulated regime, where they even went so far as to kidnap Russian scientists working in labs elsewhere, bring them back into the Soviet Union and give them all the freedom to do the research they wanted. So separating scientific freedom from political freedom, and thus accomplishing not only the first nuclear test but also the launch of Sputnik and several successes after that. Right? So science conducted under two very, very differently ideologically propelled regimes, but competing with each other neck to neck.
There was a military general, I think World War I, World War II, spoke about how plans are inevitable, but plans get thrown out at the first shot of battle. So it's the whole world is planning for making better decisions in crisis, which will allow people to play things out in their minds and think things through, but it doesn't mean that they will follow those plans necessarily. At least give them the opportunity to think about it. But you brought up a wall-free painting, and that gives me a segue into another question on what Science Gallery does. Because at Science Gallery, and two questions for you. One is, why did you make that decision to move to India and set up the Science Gallery? But the way you handle science in your gallery is also interesting. Because I've seen water, I've seen the periodic table exhibition, I missed the carbon exhibition, I'm assuming it's going to be similar. You bring together history, science, data, art in a very huge way. What's your thought on how you do that? Because that's what you refer to a quality painting. How do you think about this?
How do I think about
How
this?
do you think about the exhibitions, and how do you think about these multiple fields that you bring together?
Yeah. So I think there are certain ground rules for how we do.
And I find it fascinating, because art panels with your water exhibition for the muds from the lakes of Bangalore. Fabulous.
Thank you. Thank you very much. About this I can speak until the cows come home and go back again, but I'll keep it brief because this is obviously my current obsession. So there are certain ground rules that we follow at the gallery. Our primary audience, our target audience is 15 to 30, with a focus largely on the 18 to 28 age group, but 15 to 30 is who we look at. And so what we're trying to do is to make reach out to young people in order to build a two-way bridge between research and the public. Why does one do that? Because of the kind of things that I said earlier. We today take decisions on many things in our lives that have been shaped by research in science and the outcomes of technology, but we don't necessarily have the critical tools to take those decisions. And so how do we learn to ask the questions we need to ask in order to discern what might at least for the moment, be the correct decision for us to make? So an awareness of what's at the edge on things that making research relevant to everyday life. That's what we do. Now there are certain ground rules that we follow when we put together what I call research festivals. The research festivals are anchored by an exhibition. The exhibition ground rules are, we are agnostic to disciplines and practices, so the human, social, natural sciences and engineering, art and design come together. So we do not particularly care about which body of knowledge that piece of information or that idea or that theory is coming from, as long as it is relevant for us to understand what's at stake. Let me give you an example. When we did an exhibition on contagion, this was during the pandemic, it was online, we wanted to look at the transmission of ideas, diseases and behaviors, which meant we also looked at, for example, the contagious nature of laughter, what happens on the dance floor, the energy, the contagious nature of energy on the dance floor, computer viruses, but also pandemics. And what these other things that surround the problem that was at that moment critical, which was the transmission or the going viral or the virality of a disease, it gave you tools from areas that you might be familiar with or you feel less inhibited by in order to understand what's at stake. So you enter the problem through a door that you are comfortable with, and that agnostic approach also goes to form, or goes towards form, disciplines of form. So we use any kind of manifestation. It can be an installation, it can be a 2D rendering, it can be a 3D rendering, it can be a game. So we've developed games during an exhibition on cycling, for example. We work very closely Dancing with Goliath, a group of people making a film in California about a young person living with a diagnosis of paranoid schizophrenia who is also obsessed with computer games or video games. And his doctors and his people around him were trying to use those games to introduce therapy to him. And they were developing a film about it. We went to them and we said, can you develop for us a game where the characters in that game are the people in the life of this young person living with the diagnosis. And so the therapists, the friends, the guardians, the parents, the teachers showed up in there, and it became then a game. We did something similar also for the experience of obsessive compulsive disorder. This is an exhibition on psyche. So again, various formats, a format
And a much simpler level and a much like less complicated level and with the periodic table as well, right?
Yes.
That
So
game was fabulous.
it was our very first exhibition, and I have no idea why we thought we could even do it. I've never made a full exhibition from start to end in my life when we made elements. But one of the things, two, three things that we had that stayed with people. One was where we just had a bunch of, we created shelves arranged in the form of a periodic table, basically foot by foot, a 1 foot by foot, foot square box, all lined up to look like a periodic table. We put the labels, and then we said, okay, bring something that is of that element and put it in that box. It was quite fun, actually, because people came with things that they put it in those boxes. Then we had actual elements to touch, etc. If you look at our exhibitions today, that was probably more pedagogical than what we are today. We are far more playful now. We have things that run.
I mean, what's fascinating is all of those could make great ideas for IAs, extended essays, because they're multidisciplinary, they go across science, arts, all of that. So think about that, right? Psychology. Questions, guys. I think 1 or 2 more questions, but keep it short. Go ahead, Kabir. Call it out. Okay.
Speaking about science in times of crisis,
Yeah.
while on one hand we have to have ethics and policy to regulate our approach to science and what we should and should not look into, at the same time we also need some grounding in scientific understanding to know what that policy has to be.
Absolutely.
So do you think, in essence, our approach to policy should be science-centric? Should science drive our approach to policy, or should policy drive our approach to science?
It is not one or the other.
And also possibly how deep does your knowledge need to be before you start pursuing those questions itself, right?
Yeah.
Science is really subjects.
Yeah. No, it's not one or the other, and it's not one driving the other. They are, see, like I spoke about, I mean, the experimental nuclear physics example is very, very illustrative, because in India we saw the state being formed so agencies of the state being formed at the same time as in the aftermath of the atom bomb, right? And so what you see is the rearrangement of state agencies every time a new challenge comes up, and it could come from science and technology, it could come from other aspects of life, aspects of social and political life as well. So I don't think it can be either. It's like the chicken and egg question. I think we have to know enough in order to know what to do, and we have to know what we want. So there are some scholars who work on what are called socio-technical imaginaries, right? And what does that mean? It means that both the research and its regulation are shaped within a framework of what we imagine better futures are. If we know that, then we have a compass which we use to realign, align what's at hand. If we do not have a consensus or clarity to some degree on what these socio-technical imaginaries or what better futures are, then it's much harder to regulate. What are you regulating for? What is the purpose of regulation? So in many ways, both are not easily anticipated, right? Like when you conduct research, you might have a certain thing in mind, but the outcome might not be that exact same thing. And I'll use an example I'm most familiar with, which is Heinrich Hertz's experiments on the discovery of electromagnetic waves. It was much in the past, but he wasn't looking for them. He found them, and he understood them later, right? So you might be doing research and find something that you weren't looking for. how is regulation even to anticipate that? Because even the person who was looking for it didn't know that they were going to find it, right? So it's what you can have clarity on is what is good society, what is good politics, what are better futures. If you have a reasonable, widespread consensus on what those things look like, then your research as well as your policy can be arranged and realigned with reference to those broad contours that you have agreed upon. Otherwise, it's a very, very difficult and ad hoc kind of addressing of a situation, and that never leads to good things. Well, not never, I'll take that back. That seldom leads to good things.
Okay, one last question. Go ahead. Grade 9, therefore, Moksha.
So you spoke about the Manhattan Project and how science played an important role in that. I was wondering whether the nuclear development and research that took place in India in the 1960s can also be applied to the same because of the crisis of the Indo-Pakistan war.
Oh, the
Nuclear research in India.
So, you're saying, how do you understand the nuclear question in India in relation to the wars that India fought after independence? Okay. So, Sridhar Raghavan is a much better person to answer this question because he's a military historian, which I'm not, but I'll make an effort here. So, when the first, what was called, I think, I should remember that, the Atomic Energy Regulatory Code and the Atomic Energy Commission, various versions of it were already established starting in 1946. So this is not a product of the 60s, right? So it starts in 46, but in fact the desire to do experimental nuclear physics in India is already present in 1936, 37. So people in Calcutta, Meghnad Saha in Calcutta, Chandrasekhar Venkataraman or C.V. Raman in Bangalore are both trying to establish experimental nuclear physics in their respective laboratories because that's the frontier. Right?
Rocket Boys, guys.
Huh?
Rocket Boys.
Rocket.
The series.
So there's Sarabhai who comes and it's factually incorrect, that series.
Oh, okay.
So watch it for like drama, but
not for science.
Facts, not for facts. Yeah. So here's the thing. It starts in the late 30s. It congeals after the use of atomic weapons and in Japan and Indian independence in the mid 40s. But we don't have enough people and resources to even say that we will make a nuclear weapon at that point of time, right? You need people who understand nuclear engineering, nuclear chemistry, nuclear physics, and a range of other things before you can say you can make weapons. The people who knew enough nuclear physics to be able to walk that path were motivated by a range of different things. Meghnad Saha was motivated by energy, like for him industrialization was there. I'm making a caricature argument here, but what I'm trying to say, and that I think still holds, is that weapons were still not on the radar for them. And even if so, there was no way India could have done anything like that. The question was taken up, they were motivated by different things. What do I mean by different things? Bhumi Jahangir Bhabha, for example, whose lab was sort of, the state recognized lab or for conducting nuclear research in India, was given enough resources. He was after finding the meson in order to hopefully get the Nobel Prize, right? Like that was his quest because he had actually named the particle. And so he wanted a betatron, which is a particle accelerator. At that point of time, would have been the state of art. We eventually didn't get it. So on and so forth. But what I'm trying to say is that they were motivated to do research, they were less motivated and ready or even able to think weapons. The question becomes very serious in 1964 with the Chinese tests. It has nothing to do with the wars that India fought. 62 fought with Pakistan. 1962 is the border skirmish with China, whatever one wants to call it. 64, the Chinese conduct their tests, assisted by the Soviet Union. Between 1961 and 64, the Americans consider supporting India to have her own nuclear test in order to be a bulwark or counterweight to China in the region, and they give up on that idea. So there's something called the FRU's documents, the Foreign Relations of the United States documents. They are available online for anyone who wants to look at them. You'll find some very unsavory things about Henry Kissinger and India in there as well. So if you want to look at it, but by 1964, they've given up the idea of helping the Indians conduct tests. But 64, the Indians start taking the question of a nuclear test seriously. It is also a year of regime change. Jawaharlal Nehru, the first Prime Minister, dies in 1964. Homi Jahangir Bhabha, who's leading the atomic energy establishment, dies in 1966. As a result of which, there's a regime change in the nuclear establishment as well, or people doing nuclear research as well. There is no one after that who's doing research at the frontiers, and so the nuclear project, in a sense, begins to take eminence. It's still held back because the person who becomes in charge of the project is Vikram Sarabhai, who is a committed pacifist, also is a leader of the one of the many global leaders of the Pakwash movement, which is for nuclear non-proliferation or the use of atomic weapons as well. And so, until he dies, the question is really not on the table. But question is not on the table for conducting a test, but increasingly the question is entertained. He dies in 1971. 1966, not only does Homi Jahangir Bhabha die, but also Mrs. Indira Gandhi comes into power. And then you have that period between 1971 and 74, which is where you see the energy crisis, the oil crisis. Yeah? Look up all these things, you'll easily find them on the internet. Unlike my generation, you don't have to go to the library. Which also means global politics is flaring up again. Yeah, there's a crisis. And Mrs. Indira Gandhi also confronts a crisis of political leadership at home. People in the Atomic Energy Commission are now, by now, people who favor an India with nuclear weapons are now the dominant voice also in the Atomic Energy Commission. As a result of which, in 1974, things converge and congeal. Domestic crisis, international crisis, change of the face of leadership, change of motivations of leadership means that in 1974 India conducts its first nuclear tests. So it's a range of things. It's not war and therefore be ready for it. India couldn't have, even after 1974, been ready to use weapons in a warlike situation.
Wow. Science at the intersection, humanities, science, all of that. Thank you so much. So much more to ask and understand, but Sahasra.
Okay, thank you, Dr. Phalkey, for the session on the crossroads and intersections between the realms of science, human behavior, humanities, and state in shaping some of the world's most significant historical events. Your discussions on the role of World War II in developing the field of nuclear physics and the after effects of COVID-19 to lead to a range of thought on how delicately intertwined scientific advancement crisis solutions have been very insightful and hopefully even inspirational to some of us in the audience today. So once again, thank you so much for coming and speaking to us today about these relationships which would have otherwise been underappreciated. Please join me in a round of applause to show our appreciation.
Okay, so let's Neev take a prize.